Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Picard, and we're on our last video for Unit 11. Unit 11, Video 4, Geometric Series, which is a continuation off from sequences. Learning target, I can find the sum of a geometric series, and I can also find sums using sigma notation. And this kind of leads into what we're working with. Suppose you email a joke to 3 friends on Monday. Each of those friends sends the joke on to 3 of their friends on Tuesday. Each person who receives the joke on Tuesday sends it to 3 more friends on Wednesday, and so on and so forth. How many people have read the joke by Friday? Okay, this starts out with you sending a joke to 3 friends on Monday. Each one of those persons sends it to 3 more people on Tuesday. So 3 times 3, that'd be 9 different people receiving it on Tuesday. Then it goes to Wednesday, Thursday, and finally Friday. Okay. So if what it is continuing on, we're multiplying by 3 because each person sends it to 3 more people. 9 times 3 is 27. Actually, we can get rid of this. 3 times 27 is 81, and finally 81 times 3 is 243. The question is, how many people have read the joke by Friday? Well, Monday 3 people read it, Tuesday 9, and so on and so forth. So basically, we're just adding these all up. This is a series. And this is a geometric series because we're not adding the same thing every time. Here, if I was adding, I'd add 6. The difference between 9 and 3 is 6. Between 9 and 27, it's 18. So I'm not adding the same thing every time, but I am multiplying by the same common ratio. Okay? Our common ratio in this case is R equals 3. Still some common terms we're working with. My first term was a sub 1. 3 would be my first term. A sub 1. I don't think myself or you sending the joke would consider myself as a sub 1. And then our last one here is a sub n. Or you could also say a sub 5 because we have 5. N would equal 5 in this case. But a sub n, we've got to remember, is our last term. So we have a couple different formulas here for geometric series. The sum, S sub n. Now, usually work with, when we're working with sequences, A sub n is the term we're trying to find. S sub n is the sum of the series, the sum of all the terms in a particular series. So you can see we have 2 formulas for S sub n series. There is a difference in both of them a little bit. You're both dividing by 1 minus r. The biggest difference is this. The second formula here has a sub n. So if you know the last term, you'd probably use this formula right here. This one has r, but it also has n right here as an exponent. So if we know the number of terms, n, then we might use that formula. But these are the 2 formulas we're working with. You can use either one. So it says find the sum of a geometric series for which a sub 1 is 1,000, a sub n, your last term, is 125, and then r, your common ratio, is 1/2. So you're multiplying by 1/2. So actually this geometric series is going down, but you still have to add up all the terms. A sub 1 and a sub n are right here. We also know r, so we know everything we need to know. We don't know what n is in this case. We could probably figure it out, but that would lead us to use this formula over here. So using this formula, S sub n equals the sum of the series, a sub 1, which is 1,000, minus a sub n, which is 125, times r, in this case it's 1/2, all over 1 minus r, which is once again 1/2. So if I were you guys, I'd hit pause and try and figure out what your answer is here, because the biggest mistake I think we make is evaluating this, not necessarily plugging in the numbers, but evaluating it. So hit pause, try it, then unpause it, and I'll show you how to do it right now. Anyway, you could probably put everything in this numerator in right away and get one number. If you don't, 125 times 1/2 is going to give you 1,000 minus 62.5. 1 minus 1/2, well, that's 1/2, or just 0.5. That ends up giving us, if you subtract the top there, 937.5 divided by 0.5, and the answer is actually 1,875. So the sum of the series is 1,875. You could do it this way. Your first term, your a sub 1, is 1,000. You multiply that by half. You get 500. Half of that is 250, and half of that is 125. So a sub 1, a sub 2, a sub 3, a sub 4. There's only 4 terms, and if you add these 4 terms up, well, you're going to get your 1,875. So I'm just showing you how to use the formulas. You can do it out by hand over here, whichever way works best for you. Maria arranges some rows of dominoes so that after she knocks over the first one, each domino knocks over 2 more dominoes when it falls. If there are 10 rows, how many dominoes does Maria use? Well, you guys take a guess. If she did 10 rows, how many would she use? Anyway, just to set this up, a sub 1 is 1 domino. A sub 2, 1 domino knocks over 2. That would be 2 dominoes, and then those 2 knock over 2 each, so that would be 4. So we're multiplying by 2 here. Our common ratio, R, is 2. A sub 1, well, that's the first domino. That's 1. We don't know what a sub n is, our last one. How many dominoes? We could figure it out by doing it, this listing a sub 1 all the way to a sub 10, but I'm just going to say this. I know what n is. Well, there's 10 rows altogether. So n is 10 in this case. So I would probably use this formula right here because we don't know what a sub n is. And you need the a sub n to use that second formula for series. And anyway, finding the sum of this series using the formula, a sub 1 is 1, parentheses, 1 minus r in this case is 2, and to the nth power. So it's this r to the nth power, and I think that's where some people struggle or make mistakes, but it would be 2 to the 10th right there. All over 1 minus r, and here we go. So I think the first thing I would do is probably work your way out here. You can do the bottom, that's just going to be -1, so whatever our answer is, it's going to be divided by -1. I'm not going to get rid of this 1 yet. I know our answer is just going to be what's in the parentheses, but just to show you how things work, it's 1 minus, and I think 2 to the 10th. 2 to the 10th is 1,024. Okay, so 1 minus 1,024, that's 1 times 1,000. It's actually negative 1,023 over -1. And go over here. So it's negative 1,023 divided by -1, or 1,023 dominoes. Dominoes. Ooh, contagious diseases. Sweet. Okay. This little dude needs to wash his hands. Here's our 2 formulas. Okay, a contagious disease can spread very quickly. Suppose 5 people are ill during the first week. That's the key. It doesn't go into the week with 5 people. The first week it says. So that means a sub 1 equals 5. We start out with 5 people being sick of an epidemic, and each person who is ill spreads the disease to 4 more people. Well, there's your R. R equals 4. Each one of these 5 people we'll spread it to 4 more people by the end of the next week. By the end of the 10th week, there's our N. We're going 10 weeks altogether of the epidemic. By the end of the 10th week of the epidemic, how many people will have been affected by the illness? I know A sub 1, we started out with 5 people that were sick in the first week. Each person spreads it to 4 people, so we're multiplying by 4, not adding 4, and we're going 10 weeks. So I would say we're probably going to use that first formula again, the one where it has N instead of A sub N. So S sub N equals A sub 1 is 5 times 1 minus R, which is 4 to the 10th power, all over 1 minus 4. 5 times 1 minus 4 to the 10th. $1,048,576, all over -3. So it's 5 times, subtracting 1 from that, 48,575 it would be, all over -3. If you multiply by 5 and divide by -3, your answer should be 1,747,625. Quite a few people sick in 10 weeks for just starting out with 5 people sick. So this is kind of like exponential growth. It grows extremely fast. Okay, we're going to skip that one. We're going to go right to here. We worked with this a little bit in arithmetic series, summation or sigma notation. Summation or sigma notation is a convenient and simple form of shorthand used to give concise expressions for the sum of the values of a variable. So it's just this expression right here is just an easy way to write a series, a sum of a bunch of different terms. We just have to break it down. You guys will see this again in the future, so it's good that we're working with it now. It starts out with the summation or sigma notation. That's just this funky little looking E over here. That's your sigma notation. The expression part of it is right here. This is basically what you're going to be plugging in your numbers for N for to generate your terms. The value you start with is right here. Sometimes they don't start out with N equaling 1. They might start out with N equaling 5. And they might use a different variable than N. They might use J or K or something like that, and that's fine. But we're going to start with 1 in this case, and we're going to go all the way to 5. So 5 different terms that we're going to generate and then add together. You can just generate those terms, or you can use one of the formulas. Okay, so here's that same one, and I'm just going to generate the 5 terms and we'll look at them from there. 2 times 3 to the n power, so my first term is going to be 2 times 3 to the first power. 3 to the first power is 3. 3 times 2 is 6. Now we'll plug in the next term, which is 2. 2 times 3 squared. 3 squared is 9. 9 times 2 is 18. 2 times 3 cubed. 3 cubed is 27. 27 times 2 is 54. What do we got next? 2 times 3 to the 4th power. 3 to the 4th power is 81. 81 times 2 is 162. And finally, 2 times 3 to the 5th power, that's 243. 243 times 2 is 486. Now this is a series. So after we generate all these terms, we're going to add them all up. If you add up all these terms, you should get, oh, what did I get? 486. No, that's not right. 726. If you wanted to, You could just plug in 1 to begin with and generate your first term. A sub n equals 6. Plug in 5, your last term, and generate oh no, I'm sorry. 6 is a sub 1, my first term. Sorry about that. A sub n is my last term. And that's when we plug in the 5, we get 486. N we know is 5 because we're generating 5 terms. You can figure out R. 18 divided by 6 is 3, so I'm actually multiplying by 3 here. And you can see 18 times 3 is 54, so on and so forth. So R is equal to 3. What that means is I could use any one of these two formulas, either one of these two formulas, to find 726. So I want you guys to try that. Either pick this one or this one just to practice using these formulas to generate series, or the sum of a series. You should get 726. Okay, here's this one. I'm going to do this one. I'm going to show you how to do it, but I want you guys to hit pause and try it yourself. It's a little bit different. It's 5 to the nth power, so it's still your number is an exponent that you're plugging in, but then you're adding 7 to whatever that is. So you can generate your 4 terms and add them up, and I'll show you to you in a second. Go ahead, pause, and there we go. So our first term that we're going to plug in is 1 for n, and we're going to go all the way up to 4. So first term would be 5 to the first plus 7. 5 to the first is 5. 5 plus 7 is 12. Now we plug in 2. 5 squared plus 7. That's 25 plus 7, or a 32. 5 cubed plus 7, that's 125. 125 plus 7 is 132. And finally, 5 to the 4th, 625. 625 plus 7 is 632. It is a series, so we're just going to add up all 4 terms. And you get 808. So, a little bit more work with sigma notation, or another word for it is a summation. And we're done. Peace out, Boy Scout. We'll see you guys tomorrow.